I show this on the board, but I found this kind of cool thing on the internet, which I stole. And this thing is it's an ellipse generator. So the definition of an ellipse, I'll write it on the board, okay, in a minute. Well, I'll write it right now. But an ellipse is the set of all points in a plane x, comma, y.
What was this section called?
9.2 ellipses, okay. The sum of whose distances, the sum, I know you can't read my writing, the sum of whose distance, my Moby's squeaking for some, from two fixed points, which are called the foci, is a constant. Okay? So if I take any 2 points, okay, and it has to be in a plane, not in a three-dimensional area. But so if I take these 2 points, which I call the foci, and I take this plus this, and I take all the points whose distance from here and here, I add those together, like the distance from here to here and here to here are the same. So if I add this plus this, and this plus this, and this plus this, okay, I would get a constant. Then I generate this thing called an ellipse, okay? And so let me see if I could get something a little more dynamic. So if I move this thing around, okay, see that? The sum of those two segments is always going to be a constant number, even over here, way over here at the sides, okay? So the sum of those things is always going to be a constant, okay? If I stretch the ellipse and bring the foci closer together, what happens? What does it become?
Circle.
It becomes a circle. So the foci are straight on top of each other, like in that case, then it becomes a circle, okay? And so really, essentially, you just have one focus, which is the center of the circle. If I bring those foci way out to the ends, then I get what? If I squish it all the way out, all the way, all the way, what do I get?
A line.
I get a straight line, okay? So the further, this is kind of cool because you can see that the further the foci are from the center of the ellipse, the more stretched out the ellipse becomes. That's called the eccentricity, okay? And the distance, that's okay. The distance from here to here, okay? From the distance from the center, if this is the center of your ellipse, okay? And this is one of the foci, okay? Same thing over here. These are the same distance apart. Here's the other C over here. Distance from here to here, that's called C. The C is the distance from center to focus, okay? And the other measure that they talk about is this measure from the center to the vertex. That's called A, okay? So that's the A is equal to the distance from the center center to the vertex. Vertex to a vertex. And a vertex is the furthest point away from the center. So this is a vertex. This is like a minor vertex over here. We'll talk about that in a minute, okay? But this distance here is the distance from the center to a vertex, okay? And C divided by A has a name, and that's called the eccentricity, okay? And that's kind of the stretchiness of the ellipse, okay? So you can kind of see if C over A is close to 1, then I get what shape? Then it's, so if C and A are very close to each other, then it's very stretched, okay? It's very, very squished. What would you call that? Very stretched. Okay, so you could have, I'm not sure what word you call it, but really squishy, you know. If C over A is close to zero, then the focus is very close to the center, then what shape do I have? A circle, okay? Close to 0, then I have a circle. Okay, so that's just a word about the eccentricity of the ellipse. So if the focus is way out here, right? If C over A is equal to 1, then you have a line, right? So if C over A is close to 1, then you have a very stretched out ellipse. And if C over A is close to 0, then you have like a really round ellipse. Okay? C over A can't be negative, because then it doesn't work. Okay? So I guess I should say that's it. All right. In an ellipse, and this distance from here to here, which is kind of weird. Okay, this distance from here to here, they call that B. Okay, and B is the distance from center to, I think they call that a minor vertex, to I'm going to call that the minor vertex. Am I recording? Did I remember to record? I think I forgot to record. Did I? I'm going. I'm alive. Okay. To minor vertex, I guess. So that's this distance from the center to the skinny part of the ellipse. Okay. And it so happens, another thing that you need to know is that that it turns out that unlike the Pythagorean theorem, a squared minus b squared is equal to c squared. Okay, so those are related, and I was working on trying to look at the proof of that last night, and you can, I'll probably look at it again today because I couldn't fall asleep because I was thinking about it. But basically, you draw some right triangles and you do a bunch of algebra. The derivation is in your book. But it can be proven if you make a little right triangle with this. I don't want to get you too confused, but if this is like C over here, then you can prove that a squared minus b squared equals c squared, because this comes out to be the square root of a squared. What is that? That's the square root of b squared plus c squared. And you could go through a proof to show that a squared minus b squared is equal to c squared. You don't have to worry about the derivation or anything, but you do need to know this is true for an ellipse. Okay? So then we're going to talk about the general form. Okay? General form of an ellipse. And again, if you're interested in the derivation, you can look at it. But general form, form of an ellipse, standard form, ellipse, standard form. Looks like this, x minus h squared over a squared plus y minus k squared over b squared equals 1. Okay? Now ellipses come up in different forms, but if it's in this form, h and k tells you something specific, and a and b tells you something specific. Okay? A is always greater than b. Okay? So a is always a bigger number than b because 2a is the length of the major axis. Okay? Major axis. And 2b is the length of the minor axis.
A equals B is the circle, right?
That's correct. Because if A is equal to B, you could just multiply through by that constant, and you would get something else over here, and that would be the radius, the square root of that would be the radius of the circle. Okay? 2b is the length of the minor axis. Okay?
Y, right?
Not always. Okay? So if your ellipse, and HK is the coordinates of the center. I should write that. Okay? HK is the coordinates. Something deeper. Of the center. I think I have to recalibrate my movie. So, for instance, if this is, here's some point, I'm just going to pick some arbitrary point, HK. And what's cool about my Mobi board is I can draw ellipses with it. I used to be able to. There I go. Okay. And, not too bad. Here, I'm going to move this down. Oh, no. There. Okay. So in this case, change colors. So that's called the major axis. This is called the minor axis. It's not a very good picture. Okay? But this distance is 2b, right? And this distance from here to here is 2a. That's called the major axis. And this distance from here to here, where this is one focus, we'll call that focus 1, that's C. And the distance from here to the other focus is also C. Okay? So that's kind of what they're talking about when they talk about that. Okay, so HK, this is H, comma K over there. Get it? Got it. So now we're going to do a problem based on all that kind of stuff. All right. So, the other thing, if it goes the other way, so if it's a y minus k squared over a squared plus x minus h squared over b squared equals 1, then it's going, we could call that a vertical ellipse, so that one's kind of going like that way, okay? So if you see something where the k comes first, a is bigger than b, then it's going this way, okay? And the foci, therefore, are going to be like, the foci are always on the major axis, okay? So the foci are going to be like there and there, okay? Whereas if it's going this way, x comes first, this number is bigger than that number, and the foci are over here, okay? If it's going this way, and it's stretched this way, this number is bigger than that number, and the foci are over there. You get it? Okay? So let's do an example. Oh, and sorry, last thing. If it's just, well, it's not the last thing. It's one thing. But if it's like x squared over a squared plus y squared over b squared equals 1, then its center is where?
Origin.
Center at 0, 0. Okay, so sometimes you'll see ones like that, and other times you won't. So now we're going to do a problem. All right, so here we go. Find the center, vertices, and foci. Find the center, vertices, and foci of the ellipse with equation equation 9x squared plus 4y squared equals 36. Okay? So, like I said, ellipses, sometimes they look different than just, they're not in that nice form, but you could put this into that nice form. Who can tell me how I could put that into that nice form? Divide everything by 36. Because with ellipses and hyperbolas, unlike with circles, this number over here, to tell something about it, you need to make this into a 1. So to make this into a 1, I divide that by 36, I divide that by 36, and I divide that by 36, right? And so then when I convert that, I get x squared over what? 4. Plus y squared over 4 goes into 36 9 times equals 1. Everyone understands that? Okay. Now this one, since this number is bigger than this number, you should really rewrite it as y squared over 9 plus x squared over 4 equals 1. Because you always put the bigger one first. You don't have to, but the bigger number tells you which way the ellipse goes. Okay? And it's useful, I think, to sketch the ellipse. We're going to put arrows on the end. Put arrows on the end. There we go. So here's my xy axis. This one centered at 0, 0. It has a major axis of 1, 2, 3 of so a squared is 9, right? So a is equal to 3, right? So that means one vertex is at 0, 3, and the other vertex is at 0, negative 3. And then how far do I go out to sketch my ellipse? 2. 1, 2.
Wait, yeah, wouldn't it be the other way? Wouldn't it be B that's 3? Oh, no, because it's flipped, isn't it?
Right, so b squared. So the bigger number is always a, right? Bigger number is always a. So I put that first. Yeah? Okay? So b is equal to,
It's a vertical ellipse.
yeah, it's going this way, right? So b equals 2. You understand that? Because the number underneath the y squared is bigger than the number underneath the x squared, right?
But is it B squared under Y squared?
No.
No, I flipped it around, right? I
No, I
flipped,
get that part.
this is a squared, this is a squared, and this is b squared, okay? A is always bigger than b, okay? A is always bigger than b, because that tells you which way it's going, all right? Okay, so then I'd go out 2 and over 2, and then if you have a nice ellipse generator, like I do, you start here, and you kind of go like this. Oh, that didn't work. Uh-oh. That didn't. Let me try again. There's a better way to do it.
No,
Top right.
All right, wait.
That's A.
Start at
I'm
top
gonna,
right, go
I'm
top
gonna
right.
start here
Distance from the center.
and go. There we go. Look at that. Perfect. Okay. So
A is on the.
so there's that ellipse.
B
Okay.
is on the edge.
And the foci you also have to find. And the way you find the foci is going a squared minus b squared equals c squared. Okay. So I already know. So a squared is 9, b squared is 4, equals c squared. So c squared equals 5. So c is equal to the square root of 5. And so you would go up, since the foci are always on the major axis, I go up square root of 5, which is like 2 point something, right? So, so one focus would be here, and one focus would be there, so you could write the foci are at 0, comma, root of 5, and foci 1 and foci 2 is going the other direction, so 0, comma, negative root of 5. And that's how you do that. Questions? Gets more ugly though. Sorry, I didn't realize how long we were taking, but this is interesting. I like this. All right, so define. So here, you're going to love this one. Sketch the ellipse. Ooh, sketch. That was kind of sketchy, isn't it? Ellipse.
I play soccer. Too complicated. He just keeps going.
Find
No, I think we just have to
Subtract it and
Okay.
the x.
so this looks kind of tricky, doesn't it? I'll show you what to do. Okay. So the first thing you want to do is group all your x stuff together. So I'm going to take 25x squared plus minus 200x, and group all your y stuff together. Plus 9y squared plus 36y. And I'm going to bring that 211 onto the other side. Okay? That should be your first step. Anyone want to guess what the next step is?
factor by grouping.
Kind of, yeah, factor by grouping, more or less. So I'm going to pull out a 25 out of here. 20.
25x, right?
What?
You're going to take 25x?
No, just 25. X squared minus 200, because I'm going to complete the square in a minute. Okay? Did I do that right?
No, what? You have to take away.
Whoops! I'm stupid. Okay? No, I'm not. Okay? That should be an 8, right?
8x.
8x, okay? Plus 9 times y squared plus 4y equals minus 211, okay? Now I'm going to complete the square. 25 times x minus what?
4.
Half of that, 4 squared, plus 9 times y plus 2 squared equals negative 211 plus something else. The reason these numbers are so weird to start is because it ends up being nice at the end, okay? So what's the first thing that I'm going to add? Anyone?
16.
No, it's 16 times 25.
Whoa.
Right? Which is, 16, what's that, 400, right? Okay? And this is 4 times 9, which is 18. See that?
36.
36. I knew that. I was just checking to see who was still paying attention. Okay? That's 36. Now I squish those numbers together. Okay? X minus 4 squared plus, I made this one a really long one, it's okay. Y plus 2 squared equals, I add all that stuff up, and I believe I get a nice 225.
Wow.
Okay? Which is a nice number, because then I divide by 225. Okay?
Which is also 9.
Okay? 225, and you get, this goes in here 9 times, right? Is it at 9? 9 times. So you get x minus 4 squared over 9. plus, how many times does 9 go into 225? 25 times, plus y plus 2 squared over 25 equals 1. Okay? So I could write the y squared first. So this is a squared, right? And this is b squared. That's a 9, not a 1. Right? I mean, I should really rewrite it with the y squared first. And so now I could find where everything is, right? The center. So if I were going to graph this, okay? Graph this. The center is, where's the center? At 4, -2. So the center is at 1, 2, 3, 4, down 2. Okay? Center is at 4, -2. It is a vertical one. Since this, the number under the y squared, is bigger than the number of under here, it's going this way. So I'm going to go up 5 from 4, -2, which puts this vertex where? Up 5 from there. Where would that be?
4, 3.
4, comma, positive, that should be -2, right? 4, comma, -3. And then this, I'm going to go down, down to 4, comma, -7, right? And then I'm going to go over 3, right? So from this point, I'm going to go over 3 for the other, for the minor vertex. So that point there is going to be 1, comma, -2. And the other point over here is going to be, what's that? 3 over 7, comma, -2. And then I'm going to sketch my ellipse to the best of my ellipse sketching abilities. Let's see if I can do it this time right. Okay? Come on. No. Let me try again. Those folk guys, they're really good at playing the violin, not the fiddle and stuff.
The banjo.
Those folk guys.
The banjo.
Folk
The banjo
guys.
drums.
Hey, you made up a leader joke.
Oh, you did it.
Folk
Colton.
guys are good at playing the banjo and the fiddle.
Nice.
You get it?
Way to
Folk,
pick it.
Oh, no, we
folk guys.
I don't get it.
Folk guys.
Oh.
Folk guys.
I deserve extra credit for that.
Folk guys. The folk guys. Yeah, mama. My brother is a folk musician. I could bring in his CD so you
Oh, do
can
it.
hear it. The only problem is he thinks he can sing. So. He's a good banjo and fiddle player. He lives in Vermont. All right. How much time do we have? 5 minutes?
Enough.
I want to show you one more thing that you're going to see, and that's to find the foci. So I'm not done yet. So to find the foci, c squared equals a squared minus b squared. Okay. So c squared is equal to, we know a squared is 25. B squared is 9, right? And so I get c squared equals 16. So c equals 4. So this is a nice, neat one. So to find this focus right here, so this focus is going to be 4 above -2, which is going to put you at 4, comma, +2, right? And this focus right here is going to be at 4, comma, -6. Right? And so that's the way you do that. All right? Sorry there's so much. And the last thing is you're going to have an application problem. And I just want to find it and show it to you. Let's see if I can find it somewhere. It's in here. Hold on.
Everyone upsetting, can we stop already?
No, we have 5 minutes. Yeah. Okay, so just, you will see something like this, okay? And I do want to talk about it. With this one, it doesn't matter where you set it up. You can set up the center right here. So basically, you have an ellipse that's kind of like stretched out. So here's an ellipse, right? And the major minor axis of the orbit, like 67,900. So this would be half of that. So this would be 38, what is that? 30, what do I call it? 30, 33, 33, 950. And this would be the point, half of that would be 29, 100. And then could you figure out what the equation of that ellipse is? This is A, this is B, right?
Wait,
I mean, sorry, this is A, and this is B. I just divided that by 2 because it says that the length of this is this and the length of that is that, okay? And then you could set it up as x squared over 33, 950 squared plus y squared over 29, 100 squared. Yes,
how
Bella?
did you know that it was that,
Divided by 2.
Orientation?
yeah,
It doesn't matter. You
Okay.
could have done it the other way.
okay.
Doesn't matter, okay?
That'd be dumb.
Find the greatest and smallest distances from the center. So the greatest distance from the center is just going to be A, right? The smallest distance is going to be if this, no, the smallest distance from
From the center of the planet.
the center to the circular orbit.
It would be B.
Oh, it would be.
Just dividing it
Oh,
by 2.
no, but the planet is right here. Sorry. So the planet is right here. So the greatest, because that's what it says. With planets, right? You're going around an elliptical orbit and it goes from like that, right? Because there's gravitational forces. From the center of the planet to the satellite. So the greatest distance is going to be this plus this. So the greatest is going to be C plus A, and the smallest is actually going to be this distance right
A
here.
minus C.
Okay? Smallest is going to be A minus C. So that's the way you set that one up. And that's it. Okay? Get it? You can get it. All right. So you'll have a homework problem. You could ask about that one tomorrow. Okay?